So, let's say we have $1,000 and we're going to invest it. I got 10 minutes left. Okay. We have $1,000 and we're going to invest it at 5% growth rate. 5% growth rate. That little symbol is an old typeface symbol from the old printing press days where you had to actually take little characters and lay them in a line and lock them in place, and then you'd roll ink over it and slap paper up against it and print. So that little symbol means percent. That means per 100. So that's 5 per 100. As a decimal, if you do your division there, as a decimal, these are all equivalent. 5% is 5/100ths. That reduces to 1/20th. 20 into 1 goes 0.05. We all know that. Just a quick review. So, if I take $1,000 invested, and I'm going to let it grow at 5%, then after 1 year, this is times 0, and here's the amount of money I have. After 1 year, 5% of 1,000 is 5/100ths of 1,000. That's the same as 5 times 10 cubed over 10 squared. Let's practice exponents, folks. Cross the fraction bar with this one, makes it -2. Add them up. You get 5 times 10 is 50. So you're picking up $50 of interest after 1 year. In the next year, and remember what this is. This is 1,000. I'm going to erase the arithmetic over here, which is elementary. What we just did is we took 1,000 and we added to it the 5% times that 1,000. Right? In the next year, we now have this total investment, which is this 1,050, and we're going to add to it that interest, 5% of 1,050. So what this is, look at right here on this math in the first year. It's 1,000 times 1 plus 0.05, which is the same as 1,000 times 1.05. Okay? In the second year, it's going to be 1,000 times 1.05 to the second. So in T years, the amount of money in the investment is going to be 1,000 times 1.05 to the T. The future value, this is called. The future value with a simple 5% annual growth rate. Simple 5% annual growth rate. Everybody okay on the math? Look at the arithmetic pattern, and then it creates this exponential expression. Exponential expression. So our model for this is a future value. Oftentimes we call this A for future value. Is equal to the principal, the initial value, times 1 plus the annual growth rate to the T power. So here, and this is called the present value or the principal. Okay?
This is simple interest.
Yes, simple interest, not compounded. 5% effective growth rate. Okay? 5% effective growth rate. Feel good? So the money grows over time. Could you quickly draw a graph of this? I hope so. Is it a straight line? No, not a straight line. It is a look at this thing, folks. based on your transformations. It's a 1.05 to the x power. I'm using t for time. Okay, 1.05 is the base. We drew that earlier. Very slow growth, exponential, right? But what's the 1,000 do to it? Instead of going through 1 here, it has been vertically stretched. It's kind of like you out here, over here, grabbing a carpet and lifting it up 1,000 times higher on this end, and then all those points are 1,000 times higher than they were before. So instead of being at $1, which we wouldn't be too happy about if this was our investment, it's $1,000. So it's been vertically stretched. That 1.05 graph, very flat, is stretched up, so it ends up looking something like this over time. And this initial value, instead of being 1 initially as a knee, now that knee becomes 1,000. Feel good? And after 1 year, how much money do you have? 1,050. Feeling good. Go out to dinner with the interest. Okay? And then after the next year, is it going to just grow another 50 in the next year? It's going to grow a little more. Look at the way it curves. See, the slope between these 2 points is a change in y over change in x. In 1 year, the growth was $50 per year. And in the next year, it's going to be a little more than 50, isn't it? Because these things get steeper. Each year, they're going to get a little steeper. All right. In the last couple minutes, look at what I put into the calculator before class. Okay, look at what I put in here. We have $1,000 invested. I'll use my pencil. $1,000 at 1.05 raised to the x, where x represents years. And I'm comparing this with someone who has $10,000, 100 times 100 there. $10,000 invested at the same growth rate. Okay, you can write those equations down if you wish. And then look at the window settings I used. I went out for 16 years, putting tick marks every 2 years. Just write these numbers down if you wish to. -2, 16, 2, and then I'm showing from -5,000 to 30,000 in $5,000 scaling increments. Okay, in the interest of time, let me now just hit graph. So remember how I suggested to you earlier when you're doing demo C and demos in class, all you do is write the equations down, write the 6 window numbers down, which are here, and then draw yourself a box to show the image. So here's the graph. Remember, I went as high as 30,000 with 5,000 increments here. And then notice, here's your $1,000 investment, folks. And if I go out here to 14 years by turning trace on and go to 14 years, look at this. It's real close to doubling in value. Real close to doubling in 14 years. All right? Look at the person that instead had $10,000 invested. It's grown to this amount. And here's 5,000, 10,000, 15,000, 20,000. It too has almost doubled. If I jump onto the other graph and put 14 in there, look at that. It's very close. The same kind of a number, multiple of 10 difference between the two. So think about the person that has invested $10,000 versus you as the struggling student investing $1,000. The person with the 10,000 has doubled their money. They've made 10,000 bucks in 14 years. And if you only had the 1,000 invested, you're feeling good because you've doubled your money, but you've only made 1,000. And as I mentioned once before in class, that's the reason the rich get richer and the poor stay poor. And it's nothing, there's nothing sinister about it. It's just the interest growth rate. Okay, so question, Megan?
Is doubling time the same then, regardless of how much money you invest?
That's correct. And we're going to learn more detail about that. One closing remark. How did I suggest 14 years? All I did is I took 70. Remember this is called the rule of 70, and you'll learn why in a couple sessions from now. Take 70 and divide it by the interest rate 5%. 5 goes into 70 14 times. It's a very close estimate for doubling time. Okay? Have fun with your homework, and don't forget there's transforms on those problems. Okay, and we'll see you next session. There'll be a homework quiz.